Hi there, I'm Josh Roberts, a frontline manager at Festo GB. And in today's video, in partnership with RS, we're going to explore the three main types of equipment maintenance. These specifically being reactive, preventative, and predictive maintenance. And we're going to use a real-world example to explore each one of these, which for this will be a pneumatic cylinder. As we delve into each one, we're then going to look at the overall costs, downtime, and associated overall equipment effectiveness with each variant. Let's begin with reactive maintenance. And reactive maintenance is exactly how it sounds. You're reacting to a situation or environmental condition. And with this, we'll take one of our examples into context. So we spoke about a pneumatic cylinder, for example here. And let's say this pneumatic cylinder failed in a machine. Let's talk through the process of what would occur. In this instance, the machine, the production line, actually stops. So at this point, you call for an engineer. The engineer comes to the line. They try and find the exact fault in the machine. And let's say they found out it was this cylinder. The next steps they would go down is they would firstly identify, do they have this cylinder in stock in their stores? If they don't, then they might be taking a look if it's a standard ISO cylinder, if they can order it from a supplier. It could even be a configurable, bespoke product which may take 2 to 3 weeks. So in the best case scenario, replacing a cylinder like this, dependent on the complexity of the machine, could take anywhere from 30 minutes to a couple of hours. But in the cases that it's a bespoke cylinder, this could take 2 to 3 weeks. Now, dependent on who the end user is who's got this production line and how long it takes and the volume of product, this unplanned downtime, which could be anywhere from a couple of hours to 2 to 3 weeks possibly, could be costing them tens to hundreds of thousands of pounds of lost production. So now let's step into preventative maintenance. And preventative maintenance is just how it sounds. It's trying to prevent any reactive maintenance. So with preventative maintenance, let's take a production line in this case. The actual OEM who created the production line will typically give the end user a maintenance schedule. And this could be every 2 to 3 months or a couple of weeks, a schedule and standard maintenance activities which should be performed. All equipment suppliers that provide equipment into that production line will also have guide maintenance for stuff like lubrication to be applied into the piston rod or cleaning down any, say, guides. Now, with preventative maintenance, with the schedule, typically a technician would walk into the production line at planned downtime, which isn't impacting production loss, it would all be planned. So now it doesn't impact the overall equipment effectiveness of the complete production line. Now, what the technician would be looking for is to be walking around in the machine or listening from afar, trying to detect standard faults within a platform. So let's take our example at the very start of a pneumatic cylinder. Let's run through some of these sort of standard faults. So if I take this pneumatic cylinder here, typically we would have two types of motion, the forward motion and then the return motion. Now typically what might be happening here is you have a front nose seal, and on this front nose seal, because there could be side loads on the piston rod, this front nose seal can become loose and then start to leak. We may also see things like spotting corrosion along the side of the piston rod itself, which may impact environmental conditions going into the actual cylinder itself. And finally, all of the pneumatic cylinders typically have grease inside of them to allow a smooth operation. But let's say if lubricants came into the system, this could wash all that grease away and cause what we call dry running. And in this case, all the seals inside the cylinder would start to fail and wouldn't perform as we would like. Now, with preventative maintenance, we can detect all of these. But preventative maintenance is only as good as the technician who's performing it. Preventative maintenance does not remove reactive maintenance, it just minimises reactive maintenance. So finally, predictive maintenance. And for predictive maintenance, we want to try to predict early failures as soon as possible. And to do this, we use a wide array of sensors across the machine to get data back to make decisions quickly and efficiently. So let me just go through a couple of these. We may utilise a pressure sensor to detect the integrity of the pressure to the main line of the machine, or maybe at the subcomponents, as we said, a pneumatic cylinder earlier, to make sure the right pressure is getting to the platform, or even look at trends like pressure loss. We could utilise flow sensors. Flow sensors can also be used to measure the actual air consumption. So then we can look at leak rates and detect if we've got a leak in the system, as we said about that pneumatic cylinder at the start, the failure at the front nose seal, and monitor our overall air consumption, which is our energy consumption of the platform. And our final sensor would be a standard pneumatic proximity sensor on a cylinder. This would detect the position of our cylinder in the application, but also with the data coming back, we can start to look at the cycle time, moving from position A to B, and see the integrity of the overall platform using these sensors. So when we put all this data together, we can start to utilize the data to predict early changes in the platform. So as we move through these stages of reactive to preventative to predictive maintenance, what we're actually achieving here is by utilizing all this data, we're minimizing all the challenges of the previous two. With the predictive maintenance, we know the exact part which is going to fail. So we don't have an engineer going through the machine trying to find the part that's going to fail, but also we're not relying on their knowledge, skills and experience to detect it as early as possible. But because of this data and all the information we're getting back, these sensors pick up even the most subtle changes before they're even available. So let's take an example, an air leak. An audible air leak that we all hear on a production line. Actually, with the data of a flow sensor, we could start to pick up that trend before a skilled engineer could pick it up from the audible hissing in a production line. So, please don't forget to like and subscribe for more engineering content from RS, because over the next couple of videos, we'll be showing you step by step how to move from reactive maintenance to predictive maintenance.